Are you struggling with mole conversions? Most students just memorize the steps but mess up the setup, especially when switching between grams and moles. In this video, I'll show you how to use the molar mass to go both ways, from grams to moles and moles to grams, and we'll practice with both elements and compounds. So if we look at our first example, if we're given 32 grams of oxygen and we want to convert that to moles, how can we do that? Well, the first step is to find the molar mass. For oxygen, it's going to be 16 grams per mole. Now this value you can just find by looking at the periodic table. After that, we want to set up our conversions. What this means is that we want to find our conversion factor in order to cancel out our grams and end up with moles. So since we found the molar mass, we have a conversion of grams to mole within this unit. So if we start with our 32 grams of oxygen and we multiply it by our conversion factor, which is our molar mass, we're going to do 1 mole is 16 grams. Now the reason I put grams on the bottom and moles on the top is that we have grams on the top here. So if we want to cancel out our grams and have our answer be in moles, we need to have 1 unit on the top and that same unit on the bottom of another fraction, because then we can cross cancel. So with this setup, we can cancel the grams here on the top and cancel the grams here on the bottom. And now our only unit left is going to be moles. So now we just multiply just like we normally would with fractions. So we would do 32 times 1 over 16, which is 32 over 16, which can be simplified to 2 moles. Let's look at it the other way around. We're given 0.25 moles of calcium and we want to convert it to grams of calcium. So we're going to do the same thing that we did before. We're going to find the molar mass of calcium, which comes out to be 40.08 grams per mole. So in 1 mole of calcium, we have 40.08 grams. Now we're going to set up our conversion factor. So we're going to look at our starting amount, 0.5 moles of calcium, and we want to figure out how can we cancel moles, leaving us with only grams. Well, again, we're going to make sure we. So we're going to put our 1 mole of calcium on the bottom this time, and we're going to put our 40.08 grams of calcium on the top. So now we have moles of calcium on the top, moles of calcium on the bottom. We can just cancel them out. And then we just multiply like normal, and we end up with 10.02 grams of calcium as our conversion. Let's look at these conversions with compounds now rather than just individual elements. So if we have 90 grams of H2O of water and we're converting it to moles, how can we set this up? Well, the first step that we always did was finding the molar mass. So we just need to find the molar mass of water, which is just going to be adding the molar masses of our 2 hydrogen and our 1 oxygen. So we have 2 hydrogen, each being 1.008 as their molar mass, and we're going to add it with our 1 oxygen, which has a molar mass of 15.999 or 16. Our total molar mass for water is going to be 18.016 grams per mole if we're going to be exact. So all we did to get the molar mass of water was add the molar masses of hydrogen and oxygen, making sure to take into account the number of atoms of each we have. So now we're going to set up our conversion. We're going to do our 90 grams of H2O, and we're going to multiply it by our conversion factor. We have grams on the top, so we're going to put our 18.016 grams on the bottom, meaning we're going to have 1 mole on the top. Again, we're going to cancel out grams of H2O on the top with grams of H2O on the bottom, and we're going to do 90 times 1 over 18.016, which we can rewrite as 90 over 18.016 moles, which just simplifies to 5 moles of H2O. Let's look at one last example. Try this one out on your own, and then we'll look at it together. So we're given 2.5 moles of carbon dioxide of CO2, and we want to convert this to grams. Well, the first thing we need to do is find the molar mass of carbon dioxide. So we'll get the molar mass of carbon, which is just going to be 12, or specifically 12.011. And then we want the molar mass of oxygen, but we have 2 of them. So we're going to do 2 times our molar mass that we saw before of 15.999. And when we add these 2 together, we're going to get a total molar mass of 44.009 grams per mole. Now let's set up our conversion. We're going to do 2.5 moles of CO2, and we're going to multiply this by our molar mass, so 44.009 grams of CO2 on the top and 1 mole of CO2 on the bottom again, so our moles cancel out. Now we're going to multiply straight across. 2.5 times 44.009 will give us 110 grams of CO2. Here's where most students mess up. They will plug the molar mass in backwards, which will end up giving the wrong units. So if we're given a certain amount of grams, most students will just look at the grams per mole conversion and put it in that order, with grams being on the top, moles being on the bottom. This won't work because our grams won't cancel out. So you need to make sure that you check that grams cancel when converting to moles and our moles cancel out when converting to grams, which may mean flipping our conversion factor. If you want more detailed examples, including multi-step problems and trickier compounds, you can check out my full stoichiometry breakdown, which will be linked below. And if this helped, subscribe for more tutorials.